Hey class, tonight we're going to be looking at lesson 6.3, estimating fraction sums and differences. Let's begin by looking at our essential question. How can you make reasonable estimates of fraction sums and differences? Well, let's begin by we know that sums is the answer to addition problems, and we know that differences is the answer to subtraction problems. So let's begin by unlocking the problem and looking at the word problem. Kimberly will be riding her bike to school this year. The distance from her house to the end of the street is 1/6 mile. The distance from the end of the street to the school is 3/8 mile. About how far is Kimberly's house from school? Well, let's begin by breaking apart the word problem and figuring out the question we need to solve. The question is about how far is Kimberly's house from the school? Now, our question contains a very key word. It's about. And we know when we see the word about, that means to estimate or round. Let's look at a couple other key pieces of information. We have that her house to the end of the street is 1/6 of a mile, and the distance from the end of the school is 3/8 of a mile. So, it says that you can use benchmarks to find reasonable estimates by rounding fractions to 0, 1/2, or 1. So let's begin by looking at one way we can do this, and that is to use a number line. So we're going to estimate 1/6 plus 3/8. So we will begin by creating our number line, and at the top we will have it broken down into our sixth, and then at the bottom we have it broken down into our 0, 1/2, and 1. So we will start by placing a point at 1/6 on the number line. So there is our 1/6 on the number line. And we see the fraction is between 0 and 1/2. The fraction 1/6, after looking at it on the number line, is closer to the benchmark. And if we see that, we're only one space away from 0, whereas to get to the half, we'd have to hop 2 times. So we see that the fraction 1/6 is closer to the benchmark of 0, and therefore we would round 1/6 to 0. Now the next step says to place a point at 3/8 on the number line, and as you can see, we've done a separate number line that is broken down into eighths at the top and our benchmarks of 0, 1/2, and 1 at the bottom. And we see after we've placed it at 3/8 that the fraction is between 0 and 1/2, and the fraction 3/8 is closer to the benchmark of 1/2 because we only have to take one hop to get to 1/2, whereas we would have to take 1, 2, 3 hops to get back to 0. So the fraction 3/8 is closer to the benchmark of 1/2, so we would round to 1/2. Now we would add the rounded fractions. So we rounded our 1/6 to 0, we rounded our 3/8 to 1/2, so our estimate of how far it is for Kimberly's house from school is 1/2. Now let's look at another way that we can use to find the estimated sums and differences, and that is to use mental math. So you can compare the numerator and the denominator to round a fraction and find a reasonable estimate. Those are our keywords, reasonable estimate. So we will begin by estimating 9/10 minus 5/8. So the first step is to round 9/10. But you want to keep in mind, think to yourself, the numerator is about the same as the denominator. We notice in 9/10 we are only one piece away from the whole. We got 9 out of the 10 pieces, so we are very close to having a whole. Therefore, we would round the fraction 9/10 to 1. Now let's look at our next fraction. It says to round 5/8, and we're going to think to ourselves, the numerator is about half the denominator. We know that half of the denominator would be 4. 5 is just one step away from 4, so we would round the fraction 5/8 to 1/2. So then when we come down to subtract, we would have 9/10 is rounded to 1, 5/8 is rounded to 1/2. When you subtract those, we know that we have to find our equivalent fraction for the whole, and that would be 2/2, and 2 minus 1 is 1, and our denominator stays the same at 1/2. So 9/10 minus 5/8 is about, which means we're rounding, is about 1/2. Okay, let's take a look at another problem. We're going to look at 2 7/8 minus 2/5. So the first thing we're going to do is start with our mixed number right here of 2 7/8. And we notice in our fraction of 7/8 that our 7 is only one piece away from being a whole, because we have 7 out of 8 pieces. Therefore, since we're only one piece away from the whole, we would round 2 7/8 to 3. Now let's look at our next fraction of 2/5. Well, we know that half of 5 is 2.5. And since we have 2 as our numerator, we have 2 out of the 5 pieces, and we have to keep in mind our benchmarks of 0, 1/2, or 1. And since we know that 2.5 is half of 5, we are very close to the half. So then we can set our problem up as 3 minus 1/2. Okay, in order to answer this, we know that we have to change our 3 into a fraction. So we've got 2 as our denominator because we want to keep the same denominator as our other fraction. And it's going to be 6/2. We keep our bottom number the same. And we know that 6 minus 1 equals 5/2. Now we have an improper fraction or a fraction greater than 1. So in order to convert that, we have to take our 5 divided by 2. We know that's going to be 2, 4, and that's going to leave us with 1. Our numerator becomes the 1. Our denominator stays the same at 2. So our answer is 2 1/2 as the estimate. Okay? And we're going to look at one more problem. And that's going to be our 1 8/9 plus 4 8/10. So we're going to start with our first improper fraction, or our first mixed number, and that's the 1 8/9. So if we look at it, the fraction portion of it, we see that we have 8 out of the 9 pieces. And since there's only one number away from 9, we can round that up to the next whole number. So when we would round, that 1 8/9 would equal 2. Now we look at our second mixed number, and that is 4 8/10. And we see that we have 8 out of our 10 pieces. We know that half of 10 is 5. And between 5 and 8 would be 3 jumps, and between 8 and 10 would be 2 jumps. So we are actually closer to the whole number than we are to the half. So we would round 4 8/10 to 5. And then we simply add 2 plus 5, and when we estimate these two mixed numbers, we see that it is about, don't forget the word about to show that we rounded, about 7 is our answer. Now we're going to jump over and look at a couple of our hot problems from page 254. So go ahead and turn over to those, and we're going to take a look at problems 19 and 20. So let's begin with problem 19. Explain how you know that 5/8 plus 6/10 is greater than 1. Well, in order to answer that, we know that both fractions are close to the benchmark 1/2. They are both greater than 1/2. So two fractions which are greater than 1/2 and are added together will equal a number greater than 1. So let's look at our fractions. We have 5/8. We know that half of 8 is 4, so the fraction 4/8 is less than 5/8. And if we look at 6/10, we know that half of 10 is 5, and we keep our denominator, and we know that 6/10 is greater than 5/10. So we see that when we would add 5/8 and 6/10 together, since they're both greater than 1/2, the sum would equal a number greater than 1. Now let's look at our next question, number 20. Nick estimated that 5/8 plus 4/7 is about 2. Explain how you know his estimate is not reasonable. Well, when we look at our two fractions of 5/8 plus 4/7, when we would round 5/8, we would round down to 1/2 because we're only 1 away from our half of 4/8. And when we would round 4/7, we would also round to 1/2 because we're closer to the 3.5, which is half of 7, than we are to the whole number of 7/7. So, therefore, 1/2 plus 1/2 equals 1. So 5/8 plus 4/7 is about 1 and not about 2. Okay, so now let's take a look at our password problem of the day. Mia hikes 3 2/10 miles on Saturday and 4 8/10 miles on Sunday. About how far does Mia hike in all? Is it 2 miles, 6 miles, 8 miles, or 9 miles? Be sure you calculate the answer out and record it in your journal and bring it with you to class tomorrow. We'll see you then.